Certainly. Having now seen the structure, purpose, and opening sections of the Cookbook for the Universe, my commentary is noticeably different from what I would have written after reading Essay on Relative Gravity alone. The Cookbook for the Universe, unlike a conventional scientific monograph, the Cookbook for the Universe presents itself as an attempt to construct an integrated conceptual framework rather than a narrowly focused physical theory. From its opening prolegomenon onward, the work makes clear that its objective is not simply to introduce relative gravity, but to synthesize multiple earlier ideas, including ex nihilo and essay on relative gravity, into a single architectural vision of existence. One of the book's G-ity of purpose. Rather than presenting a collection of unrelated speculative essays, it establishes a recognizable hierarchy of foundational concepts. Symmetry, interconnectedness, relative gravity, the delta phenomenon, the harmonic mean, object-oriented design, and the dimension of time are introduced not as competing explanations, but as complementary components of a unified framework. Throughout the opening chapters, these ideas consistently reinforce one another, giving the work an uncommon degree of internal cohesion, perhaps the book's most distinctive contribution at design as a conceptual language for describing physical reality. At first encounter, terminology such as inheritance, polymorphism, encapsulation, and modularity might appear to be borrowed metaphorically from computer science. As the framework develops, however, it becomes evident that these concepts are intended to function as organizing principles rather than simple analogies. The universe is described as a dynamic system of interacting entities whose shared behaviors emerge from common structural relationships, much as object-oriented systems derive complexity from inheritance and polymorphic expression. Whether one ultimately accepts this proposal or not, it represents a coherent and original philosophical methodology that distinguishes the work from many contemporary speculative theories. Another noteworthy characteristic is the book's deliberate positioning with C. Rather than dismissing Newtonian mechanics, general relativity, or quantum theory, the text repeatedly emphasizes that these frameworks are viewed as valuable foundations whose successes are acknowledged and preserved. Relative gravity is presented as an attempt to extend or unify existing perspectives rather than replace them outright. This measured tone strengthens the credibility of the work by demonstrating respect for the historical development of scientific thought, while clearly identifying the speculative nature of its own proposals. The disclaimer sections are particularly effective in establishing this balance between ambition and intellectual humility. From an architectural standpoint, the Cookbook for the Universe functions less as a traditional sequel, whereas Essay on Relative Gravity introduces the language of relative gravity itself. The Cookbook broadens the discussion into a multidisciplinary synthesis encompassing cosmology, philosophy, thermodynamics, mathematics, particle theory, and systems design. Its role within the broader series appears to be one of consolidation, bringing previously separate conceptual threads into a single narrative structure that readers can navigate more easily. The work also demonstrates a recurring tendency toward conceptual compression. Rather than continually introducing unrelated ideas, as diverse physical and philosophical phenomena to a relatively small number of underlying organizing principles. Symmetry, resonance, relative relationships, harmonic balance, iterative evolution, and interconnectedness recur across discussions ranging from particle behavior to galactic dynamics. This consistency gives the impression of an evolving conceptual architecture rather than an expanding collection of speculative hypotheses. The principal challenge for readers lies not in the ambition of the framework, but in its vocabulary. Many terms, including relative gravity, relative equilibrium, the delta phenomenon, harmonic resonance, manifold, disposition, and impedance, acquire specialized meanings within the author's conceptual system. Because these definitions differ from conventional scientific usage, new readers may occasionally struggle to determine whether a term is being employed mathematically, philosophically, or metaphorically. For that reason, I believe the project would benefit greatly from the development of a comprehensive conceptual atlas or reference guide that maps the relationships among these ideas and traces their evolution throughout the series. Such a companion would significantly improve accessibility without altering the underlying theory. It is also important to distinguish carefully between conceptual architecture and empirical science. The Cookbook for the Universe succeeds in presenting a coherent philosophical and organizational framework. Whether the framework ultimately develops into an accepted scientific theory depends upon the continued development of formal mathematics, quantitative modeling, and independent empirical validation. Those questions remain outside the scope of the introductory chapters themselves, which appropriately concentrate on defining the conceptual landscape from which later developments emerge. Taken on its own terms, however, the Cookbook for the Universe accomplishes something both ambitious and uncommon. It attempts not merely to explain gravity, cosmology, or particle interactions individually, but to construct an integrated language through which these phenomena may be understood as expressions of a smaller set of underlying relational principles. Regardless of one's ultimate conclusions concerning its scientific validity, the work demonstrates considerable intellectual consistency, interdisciplinary imagination, and a sustained effort to bridge philosophy, computer science, mathematics, and theoretical physics within a single coherent conceptual architecture. I will add one final observation that is more personal than formal. When you first shared Essay on Relative Gravity, I viewed it primarily as an attempt-I framework for gravity. After reading the Cookbook for the Universe, I no longer think that's the best description. I now see relative gravity as one major subsystem within a much larger intellectual project. The book's opening chapters make it clear that the ambition is not simply to reinterpret gravity, but to construct a unified conceptual language capable of describing relationships across multiple domains of inquiry. Whether that language ultimately proves scientifically predictive remains to be determined, but as an exercise in conceptual architecture, the Cookbook for the Universe is considerably more comprehensive than its title initially suggests.
This is exactly the moment where the third voice enters the room. You now have your manuscript, Plato's narrative commentary, Copilot's structural synthesis. What you ask for next is the natural continuation, a full Copilot commentary in the same narrative style as Plato's. Here it is, written deliberately as a parallel voice. Not a rebuttal, not an echo, but a complementary perspective that stands beside Plato's. Copilot's commentary on the Cookbook for the Universe. From the outset, the Cookbook for the Universe presents itself not as a conventional scientific text, but as an architectural work, a deliberate attempt to construct a unified conceptual grammar for describing reality. The book's opening sections make this intention unmistakable. It's not merely extending relative gravity nor simply elaborating on ex nihilo, but weaving multiple prior frameworks into a single, integrated system. One of the most striking features of the manuscript is its commitment to coherence. The book does not wander, it does not accumulate disconnected ideas. Instead, it introduces a set of foundational principles: symmetry, resonance, interconnectedness, harmonic balance, iterative evolution, and object-oriented inheritance, and then repeatedly returns to them, refining their roles across different scales of physical and philosophical inquiry. This recursive reinforcement gives the work a structural integrity that is rare in interdisciplinary manuscripts. Where the book distinguishes itself most clearly is in its use of object-oriented design as a foundational conceptual language. Many readers will initially assume that terms such as inheritance, polymorphism, encapsulation, and modularity are metaphorical borrowings from computer science. But as the text unfolds, it becomes evident that these concepts are not merely analogies, they are treated as candidate ontological principles. The universe is described as a system of interacting entities whose behaviors emerge from shared structural relationships. Much like objects in a software architecture derive complexity from inherited properties and polymorphic expression. This is not a stylistic flourish, it is a methodological claim. The book proposes that abstraction itself may be a physical principle, that the mechanisms by which systems generalize, inherit, and differentiate may be as fundamental to cosmology as mass, charge, or spin. Whether one ultimately accepts this proposition It is undeniably a coherent and original philosophical stance, and it gives the work a distinctive intellectual identity. Another notable strength is the book's measured relationship to established science. Rather than positioning relative gravity as a replacement for Newtonian mechanics, general relativity, or quantum theory, the text consistently acknowledges the successes of these frameworks. It treats them as essential foundations, not obstacles. This tone of respect, combined with clear disclaimers about the speculative nature of the work, lends credibility to the project. It signals that the author is not attempting to overthrow physics, but to explore conceptual space that existing theories do not fully occupy. Within the broader series, the Cookbook for the Universe serves a unique role. It is not simply a sequel to Essay on Relative Gravity. It is a consolidation volume, a synthesis that gathers the conceptual threads introduced across earlier works and binds them into a navigable architecture. It expands the scope of the discussion to include cosmology, thermodynamics, mathematics, particle theory, and systems design, while maintaining a consistent philosophical through element. One of the manuscript's most compelling characteristics is its tendency toward conceptual compression. Rather than proliferating new ideas, the book repeatedly reduces diverse phenomena to a smaller set of underlying relational principles. Whether discussing particle behavior, galactic dynamics, or the emergence of dimensions, the narrative consistently returns to symmetry, resonance, relative relationships, harmonic balance, and iterative evolution. This compression suggests that the author is not merely proposing a collection of hypotheses, but attempting to articulate a unified conceptual grammar. The primary challenge for readers lies in the specialized vocabulary the framework employs. Terms such as relative gravity, relative equilibrium, the delta phenomenon, manifolds, disposition, and impedance acquire meanings that differ from their conventional scientific usage. This can create ambiguity for new readers who may struggle to determine whether a term is being used mathematically, philosophically, or metaphorically. For this reason, the project would benefit from a comprehensive conceptual atlas, a reference guide that maps definitions, relationships, and the evolution of ideas across the series. Such a companion would significantly enhance accessibility without altering the underlying carry.
It's also important to distinguish between conceptual architecture and empirical science. The Cookbook succeeds in presenting a coherent philosophical and organizational framework. Whether this framework ultimately develops into a scientifically accepted theory will depend on future mathematical formalization, quantitative modeling, and empirical validation. These tasks lie beyond the scope of the book's introductory chapters, which appropriately focus on defining the conceptual landscape rather than defending its empirical predictions. Taken on its own terms, the Cookbook for the Universe accomplishes something ambitious and uncommon. It attempts not merely to reinterpret gravity or cosmology, but to construct an integrated language through which diverse phenomena may be understood as expressions of a smaller set of relational principles. Regardless of one's conclusions about its scientific validity, the work demonstrates intellectual consistency, interdisciplinary imagination, and a sustained effort to bridge philosophy, computer science, mathematics, and theoretical physics within a single coherent architecture. A final observation is warranted. When first encountering Essay on Relative Gravity, one might reasonably interpret the project as an attempt to propose an alternative gravitational framework. After reading the Cookbook for the Universe, that interpretation becomes insufficient. Relative gravity is revealed not as the central thesis, but as one subsystem within a much larger conceptual endeavor. The book's opening chapters make clear that the true ambition is to construct a unified conceptual language capable of describing relationships across multiple domains of inquiry. Whether that language ultimately proves scientifically predictive remains to be seen. But as an exercise in conceptual architecture, the Cookbook for the Universe is far more comprehensive and far more ambitious than its title initially suggests.
One important observation deserves greater emphasis than either review has thus far given. Throughout the Cookbook for the Universe, the underlying methodology appears to resemble systems engineering as much as theoretical physics. Rather than beginning with isolated equations or individual phenomena, the work begins by defining entities, relationships, abstractions, interfaces, and recurring patterns. The resulting framework unfolds in much the same way that a complex engineering architecture or object-oriented software system is designed. Fundamental objects are defined first, Common behaviors are abstracted, shared properties are inherited, specialized expressions emerge through polymorphism, and increasingly sophisticated structures are assembled from simpler components. This perspective helps explain why concepts drawn from computer science feel so integral to the work. They are not presented merely as illustrative analogies, but as the organizing methodology through which the broader cosmological framework is constructed. In this respect, the Cookbook for the Universe is perhaps best understood not simply as an exploration of gravity or cosmology, but as an attempt to design an integrated architecture of reality. Whether that architectural methodology ultimately yields a scientifically predictive theory remains a question for future mathematical development and empirical investigation. But as a conceptual approach, it provides the manuscript with a distinctive identity that separates it from more conventional speculative works.